Good day to Doctor. My name is Ngu Tien Yu and my matrix number is 215150. So now I will present my assignment 1, that is video presentation of fluid features and dimensional analysis. The objective of this task is to understand the fluid properties, identify types of fluid, and understand about numerous dimensions, units, and concept of dimensional homogeneity. First of all, let me introduce what is fluid. Fluid is any substance that can flow, for example, solid, liquid, and gas. Maybe some people will wonder how solid can be classified as solid. However, most of the industry use the solid as the raw material, and it can flow through the pipe with the ease of some lubricating oil. Let's move on to fluid properties. Fluid can be in liquid or gas form as long as it can flow through the area of interest or a particular region. Actually, there are many fluid properties. However, I will explain the more important one with respect to the knowledge of Department of Chemical Engineering. The first one will be density. Density is mass per unit volume of a substance, and its SI unit is kg per meter cube. The second one is specific weight. Specific weight is the amount of weight per unit volume of substance. So below will be the derivation based on the definition on the specific weight. The SI unit is meter cube per kg, which is the inverse of density. Next will be the specific gravity. There are two general definitions based on two aspects, that is in terms of density and specific weight. Specific gravity is a ratio of density of a substance to the density of water at 4 degrees Celsius. It can be also the ratio of specific weight of a substance to the specific weight of water at 4 degrees Celsius as well. So we can clearly see that the relationship between density, specific weight, and specific gravity. Note that specific gravity has no unit because it is the ratio of a variable due to the rule of dimension, which will be discussed later. Temperature is the degree of hotness or coldness of an object. It may be affected by the pressure and volume of the object. In most of the subjects learned in chemical engineering, like chemistry, thermodynamics, energy balance, and so on, we are required to calculate the temperature based on the absolute temperature. It is because the absolute temperature is a 0 point corresponds to the condition where all molecular motion, that is rotational, vibrational, and translational motion stops. The absolute temperature will always be the reference temperature for us to calculate the temperature related to the flow of chemicals. The SI unit is in degrees Celsius. However, it is very important for us to know how to calculate the absolute temperature, that is 0 Kelvin. So some of the formula is derived to get that absolute temperature and is shown in this slide. Next is the pressure. Pressure is the amount of force exerted per unit area of a substance on a surface. The SI unit is Newton per meter square, or commonly known as Pascal, that is PA in short. And the most important thing is force vector must add up perpendicularly to the area. There are two instruments that we learn in the pressure measurement in fluid mechanics. That is, the first one is barometer, which is to measure the atmospheric pressure, and the second one would be manometer, which is to measure the gas pressure in gauge pressure unit. Compressibility is the change in volume of a substance that is subjected to a change of pressure on it. All of the substance can be compressed, including the solid. The strength of compressibility will increase from solid to liquid, then to gas. Vapor pressure is the pressure exerted by a vapor in thermodynamic equilibrium with its condensed phases, which most probably will be in the solid or liquid form at a given temperature in a closed system. Now, to calculate the vapor pressure, we will use the Anton equation that can be found in Paris Chemical Handbook. The equation is shown to be the right-hand side, which can be determined by using the mole fraction in the liquid and vapor phase, which we call the formula of Ross's law. The last fluid feature is viscosity. It is the internal resistance of a fluid to the motion which is caused by the molecular attraction, and the flow of fluid is opposed to the flow of motion. This feature is much vital for the concept of fluid mechanics, as it is used to classify the types of fluid. So now let me introduce the types of fluid in the concept of fluid mechanics. It can be classified to Newtonian fluid and non-Newtonian fluid. For Newtonian fluid, it follows the rule of Newton's law of viscosity. It is the fluid where the shear stress is directly proportional to the velocity gradient with a constant viscosity at a fixed temperature and pressure. Now, most of the common fluid, such as water, gasoline, oil, alcohol, and benzene, are Newtonian fluid. For non-Newtonian fluid, it does not obey or follow the Newton's law of viscosity, and the viscosity is dependent on the velocity gradient in addition to the condition of fluid, meaning to say that the relationship between shear stress and velocity gradient is not linear. For example, pseudoplastic, dilatant fluid, Bingham fluid, and rheoptic fluid are the non-Newtonian fluid. Just now I have mentioned about the term of shear stress and velocity gradient. So what are they actually? Shear stress is the force to slide layers of an area of a substance over one another. The velocity gradient is the measure of the velocity change which corresponds to the velocity of the fluid flow to overcome the shear stress. In the graph below, you can see that the velocity gradient of Newtonian fluid is linearly proportional to the shear stress, while for the other fluids, the velocity gradient is not that linearly proportional to the shear stress. Enough with the fluid features, which is more on theory. So now let's discuss our last objective, that is on dimensional analysis. So for dimension is defined as a technique used to describe a physical quantity in terms of its basic quantity, regardless of the system of unit used. So usually square brackets will be used to denote the dimensions of a physical quantity. So you can see in this example, the physical quantity of mass is denoted as small m. And we will use the bracket to cover the alphabet to denote it is a physical quantity. Pure numerical factors or number like natural number, pi, fraction, and even decimal usually will be ignored in doing the dimensional analysis because they have no dimension or there is no physical quantity to denote them. Thus, in overall picture, dimension can be treated as the algebraic quantities through the procedure called dimensional analysis. Dimensional analysis is a procedure by which the dimensional correctness of an equation can be checked with its correct unit. There are some uses of dimensional analysis. The first one is to determine the unit of physical quantity. Second is to derive the mathematical expression and equations. Third, to check the correctness of physical equation by using the principle of homogeneity, that is the dimension on the left hand side will be equal to the dimension on the right hand side. And the last one is to convert the SI unit to other convenient unit. Here will be the rule when doing the dimensional analysis. It is hard to explain how to do the dimensional analysis by not providing the example on how to do it. So later I will do some handwritten example on how to do the dimensional analysis by using the dimension technique. Before that, we should also note what is basic quantity and derived quantity. Basic quantity is the quantity that is common and fixed and cannot be derived by using other quantity. So for derived quantity block, it is derived from the basic quantity and other derived quantity as well. Alright, now so before I'm going into the example, so let me emphasize again on the dimensions. So dimensions is defined as the method used to describe the physical quantity in terms of a basic quantity regardless of the system of the unit used. So normally we will use the square bracket to denote the dimension of a physical the dimension of a physical quantity. So if, for example, if flame will use L to denote mass, we will use capital M, and also time we use capital T to denote the dimension of a physical quantity. So there are two types of quantity here. Number one will be basic quantity, which shown in here, and a symbol dimension. So it is a quantity that cannot be derived in terms of other physical quantity, while the derived quantity is derived from the base quantity, or it can be derived from other derived quantity as well. Okay, what I mean here will be shown in letter. So for the rules of the dimension for derived quantity blood, if the dimension is the add out of the is a summation of a dimension, so the rules will be always the same, because when we add up the, like I say, add up the physical quantity, the dimension must be the same so that they can have the same unit to add up lah. Okay, if they are multiplied, they will be multiplied. If it is over, they will be over. It is a power of the index, it will be times or the power of the index. So let's do for the derived quantity. So we know that velocity will be the displacement over time, right? So displacement, we can relate it with length. So we will use the basic quantity of length over time, that is times up. Okay, so we use the symbol of dimension to denote it. There will be L over T, and the final dimension will be LT minus 1. So that is how we determine the dimension of a velocity. And the dimension also can determine the unit of the physical quantity. So length will be referring to the meter, and T in the power of minus 1 will be per second. So this is the dimension of the velocity, while this is a unit. Okay, so this will be the dimension and this will be the units. Okay, so let's try on the accelerations. We know that accelerations will be the change of velocity over time. So just now we straight to the method of this technique of dimension. So velocity will be lt negative 1 and over time lagi, time lagi, so it will be lt negative 2. Okay, because the denominator bring to the front will be negative of the index lah. So the unit will be meter per second per second. So for force pula, we know that force is mass time acceleration. Okay, so mass we will denote as capital M, and acceleration will be denoted as Lt in the power of negative 2. So this is the dimension actually for the force. We were going to express in unit, it will be in kg meter per second per second. And also for momentum pula, it will be mass times velocity. So mass will be denoted as m and L t minus 1 for velocity. So it is very easy to determine. K is kg meter per second. Alright, so in the questions, especially solving the mathematical expressions, or you will don't memorize for the quantity, so we can use the formula and then we can solve for the dimension and to determine its units. As long as we know the formula, as long as we know the symbol SI unit and the symbol of dimensions, so it is very easy to know what is the concept of dimension by looking the example of it. Thus now we have clearly seen that how to determine the unit of a quantity by using the concept of dimensions. Now let's move on to the dimensional analysis. It is an equation in physics which is true in any unit system. A physical equation is said to be homogeneous if only if the dimensions of all the terms in the equation are the same. Okay, now we look at the dimensional analysis. So it is to check whether the equation is homogeneous or not, or we call dimensionally consistent. So one thing we have to know that the numerical factor and the number can be ignored in doing the dimensional analysis. So if the right hand side of the equations, let's say in here, if it is equal to the dimension of the right hand side, so the equation is said to be homogeneous lah. So let's look for these examples. So let's check for the dimension of the left hand side. So dimension on left hand side will be 2x. Okay, we cannot put bracket on 2 because 2 is not dimension. 2 is numerical factor or numerical method or numerical number that cannot put as square bracket to denote it is the physical quantity. So it will be s only. So it will be dimension will be L. Okay. Now dimension on right hand side. So remember for the rule of the dimension here, if y is a plus b plus minus b plus minus c, so the rules will be y dimension of y will be respective of all the dimension here. So we have to check for the right hand side because it is two terms here. There is obey the rules y equal to A plus minus B plus minus C. So we will use this rule applying here. So we have to check one by one. Same here. 2ut, 2 is the dimensionless factor. So we will take out and see this. Okay. Then finally it will be ut, and we determine u will be the velocity. Velocity will be lt minus 1, and then time t, so times with t, so will be dimension of l only. So it is the same, okay? But we have to check for another one, because the dimension will be, the rule of dimension will be correct if each term is the same. Okay, each one would be same. And then for this at square, we know that a is the acceleration, will be lt negative 2 times with t square, so it will be l. So since that left hand side or the right hand side, dia punya dimension is same, so we can say that the equation is homogeneous in dimensions, or we can say that it is dimensionally homogeneity lah. Okay, so it is very easy by just, so we need to know the symbol of dimension and the unit of the dimension. Okay, by just looking at these few examples, so it is very easy for us to understand what is dimension and also dimensional analysis. Just now I have mentioned that specific gravity has no unit, or in other words, to say that we can say that it is dimensionless. Now dimensionless number is a number that obtained by dividing the inertial force, or by viscous force, or gravity force, or pressure force, or surface force, or elastic force. Now, as this is the ratio of one force to another, it will be a dimensionless number. They are also called as non-dimensional parameters. Now, dimensionless numbers are widely applied in mechanical and chemical engineering. A dimensionless number has no physical unit associated with it. However, it is sometimes helpful to use the same units in both the numerator and denominator, such as kg per kg, to show the quantity being measured. A dimensionless number has the same value regardless of the measurement units used to calculate it. It has the same value whether it was calculated using the metric measurement system or the imperial measurement system. And that is the end of my presentation on assignment 1, fluid features and dimensional analysis. Thank you.